Dzień dobry Państwu. Witam w kolejnym wydaniu infraSTUDIO i drugiej części mojej rozmowy z profesorem Eloi Figueiredo z Uniwersytetu Lusofona w Lizbonie. Tym razem skupimy się na tym, jak zapewnić bezpieczeństwo mostów. Taką możliwość dają nam zaawansowane systemy monitoringu stanu technicznego konstrukcji, czyli w skrócie SHM, SHM, Structural Health Monitoring. Przypomnę, że rozmawiamy w języku angielskim. Zapraszam. Hello, we ended the introduction of your civil research group. Your main goal is sustainable and resilient infrastructures.
Yes.
Which of these research topics are the most important in your opinion?
So, the research topics we are tackling right now at the Civil Research Group are mainly structural health monitoring, sustainable road infrastructure materials, and hydrothermal behavioral buildings. And let me tell you that climate change or the impact of climate change is present in all those research topics.
Must be. SHM is your primary area of research, as I know from the lectures you gave us yesterday or today. I know that it will be difficult, but could you shortly say what the SHM system is?
The main goal of any SHM system is to ensure the safety of bridges and the people, of course, and but there is an operational goal that we must take into account, which is we should help authorities to better know their structures and to let them know when they should repair or maintain their bridges.
Or even replace.
Of course.
And what types of structures can be monitored this way?
Potentially every type of structure can be monitored, but I will put in first place the ones with low probability but extreme impact events like bridges, tall buildings, and offshore platforms. Why not?
And how do you find the evolution of SHM systems? What exactly it started with?
So there was the boom in the beginning of this century in the SHM. We have seen a lot of development in new sensing technology, new data methods just came up. But I think we reached the point where we must prove that there is a positive rate of return on investment for SHM.
And do you think that due to the spread of SHM systems, we will stop performing traditional visual inspection of bridges?
No, I don't think so. Look at the medicine. So, medicine came up with a lot of new technology, but we haven't stopped to have in-person visits to the doctor. So the technology is here to help, but it cannot replace the human judgment.
And which of the famous Portuguese bridges have the SHM system actually?
So, as far as I know, most of the main bridges in Portugal, the big ones, have permanent monitoring systems. I can tell you that the 25 de Abril bridge in Lisbon, for instance, have been monitored for over 2 decades or 3, I mean, roughly.
A lot of data.
Yeah, a lot of data.
Do SHM systems need to run in real time?
It depends on the application. Look, bridges don't fall down every hour, and they have very slow degradation, which means that potentially you don't need to monitor every second, every hour. So, but the point here is to find out the best sampling rate that we need in order to avoid massive amounts of data, unnecessary data, but we can't have the risk to miss information about the presence of damage. So it's a tricky question. We really need to evaluate the risk, and in order to have the optimal sampling rate.
So what elements do the simplest SHM system consist of?
Historically, most of bridge failures are caused by scarring. So if you are the responsible of an SHM system, I think you should start from scarring. Why not just install sonars to measure scarring at the foundation level? But then I will claim that it is important to measure displacements at the expansion joints. We can use transducers like LVDTs, and also we can use accelerometers throughout the bridge. We don't need many in order to measure the dynamics of the bridge, which can give us information about the stiffness, about slow degradation, and so forth.
Now, are all these elements necessary for SHM to be effective?
So, sensors don't measure damage. Rather, sensors measure data. We need to have data analysis methods to analyze this data. But it is important that this data has information. Even if it is hidden, we must have information about damage there. So we must develop very good sensors to be sensitive enough to have information from damage, but also importantly, we must develop data analysis methods in order to unveil information hidden in the data.
Mm-hmm. So I think this is probably still the most challenging part of the SHM system today. How data processing techniques have changed recently?
Artificial intelligence has made impact in the last 2 decades in the SHM field. We have moved from physics-based methods to data-based methods, and where machine learning algorithms are really playing a very important role in order to unveil their hidden information about damage.
Yeah, you mentioned artificial intelligence, so in here, this AI can turn out to be very useful. Do you often use such algorithms?
Yeah, I have been in this field for over 15 years, and I have used a lot of machine learning algorithms to analyze the data, especially for instance, neural networks, Gaussian mixture models, even deep learning more recently. And these algorithms are amazing because they can learn almost everything from the data, actually they work like the human brain, so they learn from the experience. The more data these algorithms have, the better are the indications about the presence of damage.
Mm. Algorithms are more patient than human beings to analyze data. In the first part of our conversation, we talked about Brazil. Did you also create some SHM system on those bridges?
Officially not yet, but we are planning to do so in 2022 or maybe 2023.
How do you think SHM system can be linked to more and more common beam models?
So that's a good question. BIM has several dimensions, and the development of finite element models can be one of those dimensions. And here, in particular, the SHM can have the role to fit these models in order to be calibrated, and also to give information about the structural conditions. So.
That's the concept of digital twin, almost.
Yeah.
So could the concept of digital twin be a way of such integration?
Yes. Digital twin is a new concept, just came about recently, and which may be explored to create a digital replica of the bridge, which can be managed by, permanently in order to evaluate the structural condition and to give us information in a more holistic perspective. I really like this idea.
I like too. Eloi, thank you. Thank you very much for the interview.
Yeah, thank you for the invitation.
I'm glad that starting with the rich Portuguese culture, history, and also Portuguese bridges, fantastic bridges.
Yeah.
Finally, we've reached their digital twins. It was a really inspiring journey. and let's see what it awaits us for as the future.
Yeah, research is an amazing world, Marek.
Yeah. Thank you once again. Finally, I wish you and your research group in Lusofona University good luck in your
Thank you.
research. Państwu również dziękuję za uwagę i zapraszam na kolejne edycje infraSTUDIO.